This meeting.
Hey.
Yeah, too bad we missed the first half hour of my gibberish.
Screen.
I
got it recorded, the minutes.
Oh, okay, thank you. I don't know why we're not seeing this on our screen here.
How about a new share or something?
New share? Where?
So, there.
Paul has to press the full screen button on the top.
There? That didn't help any. New share. Okay.
On Paul's computer.
We don't have my computer.
Okay.
Press the full screen icon at the top. In a
There.
red stripe.
That's what he's pressing.
That's what I'm pressing. And the only thing that's getting pressed is depression.
No, not Tom's, Paul's.
Paul is on Tom's. And I
Oh,
did
okay.
click on his. So
You got something wrong.
Are you trying to use this the slideshow
yeah,
up at the top, just under the right? Well, along the top row is the word slideshow. Click that.
slideshow.
I don't know.
Okay, hang on a second.
Over from the file tab, slideshow tab.
There you go. Give better presentations. Try it. Not now. Zoom. Pardon me? F5. F5. 3, 4. Which one is F5? Is it between?
It's the one between F4 and F6.
That's this.
Top of the keyboard.
We're going to drive him nuts here tonight.
He doesn't have
F1,
function
2,
keys.
3, 4, 5. That's the one that I just turned on.
I'm going to give you a clue, Tom. On my screen, I think I'm seeing what you're showing, okay? And there should be a little box there towards the top that says slideshow, and right below it says resume slideshow.
Slideshow.
Yeah, slideshow.
Now, down. There you go. Have you got a box right there?
Yep.
And now right below that, does it say resume slideshow?
Add or
No.
record.
No. Move your mouse. Now, can you see the word resume slideshow?
Negative. It red lines the slideshow thing.
Well,
It's in the little red box, resume slideshow.
It is.
yeah, we can all see it. I'd click it for you, but I can't run your screen.
Okay.
Ah,
Somebody help.
Do you have this on 2 screens?
oh, apparently you can't see what we're seeing.
Correct. We're seeing the very first slide, but it appears there is something behind that slide, but I'm not.
Oh, over on the left.
It's on the left-hand side there.
Yeah, but I'm not.
It's not behind it, it's so Zoom windows.
Yeah, it could be
How
the Zoom.
about double click?
You're
Double clicking.
hit the escape key because you're right now into editing the screen.
Really?
Yes. The text. There you go.
No, not for us.
All right, now go up and click slideshow across the top. Get your mouse up. There you go.
I'll resume slideshow.
Yay!
Okay.
How come we can't?
How come we can't see it?
I don't know.
We are seeing a different slide. We're seeing the first slide, but it's not going to the second slide. So I tell you what,
Double click on the picture.
click on the picture. What'd you
Double
say?
click.
Okay.
Zoom?
That resume slideshow. We've done that.
All right, take your mouse all the way over to the left and put it on the next slide and click it.
Oh no, we have no problem running it through the slides. You're seeing Glenn, aren't you?
Yes.
Yeah.
Not. We see it on my computer, but we are not seeing it on our screen.
Oh,
Yes, that's the O issue that we're having. So what I'm going to do, so that Paul doesn't get too old, We're just going to continue with this, and the people here
It's
can
happening
either,
right now.
can either, can queue up around here if they want, or they can just listen to him.
Oh,
He's very descriptive.
how do you,
Okay, remember that's just the down key.
is there a mouse?
Oh, yeah.
Yeah, okay. Is this the first, oh,
There you go.
Glenn likes to come over and work on things on his own time. And I couldn't resist getting this picture. This is a plan view of Glenn's head. If you know, architects do a plan view looking straight down. It's funny to me, I don't know. Anyway, we were donated this, at the last meeting, we were donated this 12.5-inch full thickness mirror. And I don't know if there's any interest in continuing with this, but it's near the end of fine grinding. I did some tests on it. It's exactly F6, and it weighs a lot. It weighs 22 pounds. So in a Dob, you wouldn't need any extra counterweights in your rocker box. In fact, you might want to have a separate mirror box. So anybody who wants to pursue that, they're welcome to work in my shop, grind and polish that thing. Now, we did a lot of other information exchanging, mostly blah, blah, BS kind of thing. And there's a mistake in this text.
That's not my fault.
Yeah, it might be.
Everything else is mine, but
Okay, the club's 6-inch mirror project has been very interesting. And how do I get this farther? Over many months, we've been working on this project. So I would like to highlight a few of the things that went on. Here's Tom Mosden has actually been bringing students over from ASU, not in this slide, but here's the back side of my shop there. And here is Matt Lutinen. I think this is a slide where he's actually parabolizing the 6-inch, one of the final things we did on it. Okay, where am I here? There. Many hands make light work. Here's some more. These are all ASU students. This one here is named Nivedita. She's now Dr. Nivedita, something I don't know her last name. And here's Glenn Nishimoto clowning around with the interference machine here. And Glenn's, Matt's laughing at him. Okay. Did I get this one? Yes. No? What happened here? Michael Popri, he's here somewhere.
Yeah.
He was one of the first people working on this mirror.
So blend in, it doesn't.
Yeah, and there's more of the students and so forth. Okay, finally, the 6-inch mirror is finished, saith the ATM group. Now upward and onward towards the OTA. So if you want to hear more about this mirror, I can continue or I can stop there.
who wants to hear more?
More.
Oh,
Go ahead.
Okay. Okay, first of all, Foucault test versus the interference test. Foucault test only tells you the figure of the mirror across a line across the middle. In fact, it doesn't even do that. It tells halfway from the center to the edge and duplicates that. Interference test tells you fully three-dimensional what the surface looks like. So that's what we are doing. And this is a SAC interferometer invented by Dr. Shack in the 1970s. And just to point out a few things here, this black thing in the back is a laser. It's out of some grocery store. They converted all their barcode scanners to some much better like LED lasers, some steering mirrors, and this beam from the laser comes back here behind these manipulators into the microscope objective and into this thing, which is called a SAC cube. And give you a little more about what a SAC cube is. Anyway, coherent light from the laser shines into the microscope objective, which is sort of working backward here to a tiny point. And that point of light has to be less than 5 microns in diameter, because that's the diameter of the pinhole, and you're not allowed to touch the pinhole with the beam or you get all these diffraction effects. Beam goes out, it's 2 ways. One, it goes out and hits the reference sphere. Oh, let me point out something else. This reference sphere surface has a center right at this pinhole, and the mirror being tested is the range, so its center of curvature is at the pinhole. So as you look out from the pinhole, along every path here, the distance between this sphere and this mirror under test, if this is spherical, is identical. Any way you go out, the 2 surfaces are perfectly concentric. So if it's not a sphere, then things will show up like I'm about to show you. The SAC cube has this internal reflecting surface beam splitter, which makes it more accurate than any other way previously that this could be attained. A piezo interferometer or any of the old types have a thin glass beam splitter, and that introduces spherical aberration. But the SAC cube was a really good innovation, and this is what's used in testing all big mirrors today. Okay, here's some pictures. This is in my shop looking down over the top of the interferometer towards the little 6-inch mirror down here. And at the output of the SAC cube, I have a camera set up. Now, Dean Kettleson cued me in that there's a better way to do the imaging, and he contacted some of the people there at University of Arizona and found out that using an eyepiece and a camera lens was a much better way. But here too, you can see the SAC cube. You can't really see the spherical front surface, but that surface is extremely accurate, made by a guy named Paul Anderson, I believe. And this is one of the SAC cubes that was made for the 8-meter mirror tests at University of Arizona. This one had some slight defect and was given to Dean, who loaned it to me. So this is actually kind of on loan. So the next big player in all of this is this fellow, Fritz Zernike. He found a way to map the whole surface of interference fringes, is what you see in that interferometer. And whoops, what happened here? And curve fit all of these curves, all these fringes, calculate a number of coefficients called the Zernike coefficients, and map them into surface areas. So this is the exact view of a surface looking down on it, and the colors indicate the heights. So in this case, the RMS error was an 8th wave. Now it's too bad we don't have the full movie mode here, because they had Fritz Zernike spinning around on the first slide, and these came in sequence. Anyway, I took 11 interferograms before our last meeting, which was on Tuesday, and I put them through this process and averaged the Zernikes, because the Zernike polynomials are the same for each one of these. Even though these all look so terribly different, each one leads to a set of Zernike polynomials, which is almost identical, except for slight differences between the setups. So averaging out those setups, our F5 6-inch mirror came out to be 1/8.5 waves accurate, and I convinced the rest of them that that was good enough. That you can see, well, you can see on here that the thing is astigmatic. I mean, around this axis from say 10 o'clock to down here to 4 o'clock is high, and this axis along the edges along, say, from 2 o'clock to what, 7 o'clock are low, and the peak wavefront error is of 1 wave, but the vast majority of the surface is very accurate, and 8th wave RMS accuracy is considered very good. So we're going to leave it at that. So after that, all I can say is thanks for watching.
Thank you, Paul.
Okay.
Let's see if we have any questions.
Yeah, any questions?
Let me see, do we have any questions from the participants? We're up to 22 participants.
When are you gonna mount it? Get first light on it?
Oh, it could be years. We have to make
The question was, when is he going to mount it? And his flippant response was, it could be years.
It's taking us. Yeah, less than James Webb.
That's not saying much.
We haven't put it in the tube yet.
Have you done measurements on, say, but if you haven't done the measurements, where you're gonna cut the hole and do the next?
Well, there's a program for that called Newt. And as soon as, yes, as soon as we meet again, and I think Lynn Blackburn will be back from his summer trips. He's real good at that. We'll know where to cut the holes.
Terry Shea's asking, what are you going to coat the mirror with?
Aluminum?
You going to do it or you send it out?
No, we'll send it out.
Okay, just
Not
checking.
sure yet.
Not sure.
I would like to have a vacuum chamber for that.
I'm surprised you got everything else. Make one. Okey doke. Thank you very much. Okay. Okey doke, and we are still not seeing anything up on our screen here.
Turn it on. On-off switch.
Did you ever see anything on it?
We've seen our agenda and his and Paul's first slide. So I don't know why.
Let's try something, see if we can clear it up. I'm going to share my screen and see if it brings it up.
Okay, go for it. Let's see. Nope, we're still seeing mine.
It
I
said,
see it.
okay, mine says I'm sharing and Rick
seeing-
says,
I see it.
Okay.
You see
All right.
it, Tom?
Yeah, and I see his, but we're trying to see it on our screen, our big screen here, so all the participants can see it. Otherwise, all we're seeing, and I don't know why.
Is your laptop feeding the screen?
How would I tell that?
Well, it's like,
Video.
Okay,
Are
somebody
you
can
connected?
get here, or we'll be here all freaking night. Okay, got a Mac.
I'm going to unshare so you can resume.
all right, so you've got extended, you've got extend, that's duplicate, that's PC only. And that's second screen. So which,
I don't know which.
try PC only. All right, there you
Oh,
go.
there we go. Now I, okay,
you don't.
now I don't.
That's on that, but that's okay because we're going to watch David share his screen.
Okay, yeah. David, you have the con because we are seeing you and I'm not seeing anything on my screen, so I won't be able to tell. Wait a second, let me, oh, I can work it off of your
You work
screen.
it off of there.
So yeah, go ahead and
You,
roll with it.
the duplicate should have shown both the same.
I have the con.
Stand by one.
Well,
We're gonna
but
try
that's
one.
what you were on.
That was what I was on?
Wasn't doing.
Okay, well, we'll let you go.
Well,
All right.
do you have my screen now?
Negative, we have your screen, but not your pretty face or anything other than your computer screen evidently with your icons, apps.
Okay, you have that. That's what I want to make sure of.
Okay.
Okay, if I were to do that, do we have a picture come up?
We have a picture in the upper left. Yes, you're expanding it nicely. Yes.
Okay, so we're functioning. Am I clear to proceed?
Go for it.
I'm going to go. Here we go. Well, this evening I'm going to talk about a subject which I basically titled "In Search of Double Stars" and the things that can happen when you're looking for them. I think this will be something that can be useful to many in the group because it can be done in your backyard. You don't have to go out to dark sky sites. You don't really worry too much about the moon. Double stars are viewable right from your backyard most nights. A little basic background. Astronomy became a hobby for me back in about 2004, at about the time I retired. My first few years were all visual astronomy and just enjoying the various targets that I could find. But somewhere down that road, I visited the Greco Observatory operated by EVAC, and I became seriously hooked. I upgraded my telescope to an 8-inch Meade LX200, joined EVAC, and continued visual observing. During those times, EVAC was heavily involved doing outreach programs, schools, as well as the outreach programs there at the Riparian, which they're still doing today. Not tonight, but I mean, they're still doing them. I started joining the outreach events, which led to a problem for me. The problem very simply was, what targets do you want to show the general public? I know anyone that's ever worked in outreach, quite often we have discussions about the same thing. I was still new into the game and I needed some ideas. Randy Peterson was the outreach coordinator at the time, and he suggested several targets. And I'm having a problem here. Here we go. Randy Peterson was the coordinator, and he and I talked for a while. And he gave me a list of some targets, which included 2 double stars, which remain today amongst my initial go-to targets for public outreach programs. They are just always there, and they always please. These targets were Mizar in the Big Dipper and Alberio. Yeah, I know Alberio, if you're familiar with it, is not always there. It's an right ascension at 19 hours. It is a beautiful colored pair, blue and orange, but it just so happens that Alberio has a winter twin, commonly known as the winter Alberio. There's an SAO number for it, but it doesn't have a different name. It's just the winter Alberio. This is what you have there for the photo is an actual image, not mine, but from another group, the Milwaukee Astronomical Society webpage, that shows Alberio as one would see it in a telescope. A couple of unique things come from that particular picture. First of all, it's a double star. And what do we see? 2 stars. But there's something very unique. There's color. And that's something, you got to remember, this is like 20 years ago when I was doing this, but seeing color in the telescope just wasn't there. Everything was in shades of gray, unless you were looking at Betelgeuse, and it would be red. But anyway, here we have the yellow and the blue star. Stars, some stars do exhibit color. Yellow, red, and blue are the most common. When I was able to show Alberio, it was kind of amazing because it was a crowd pleaser. That they liked the color. Back in those days, there were a lot of families that would come to these outreach events, and when you have the families, you have kids. We have kids, you have some young kids, and usually some Cub Scouts. Now, Alberio is very, very special to me. I was a former scoutmaster, and having 2 sons that grew up through scouting, you learn a few things. Something just got embedded in my brain. It's the Cub Scout colors, blue and gold. As the astronomy school events and most of the public parties, the families would see this and they would comment on it. It gave me a tie-in with the crowd. Anyway, Alberio came to the rescue as some of the early things that I would do with that. That was my first introduction to a double star. The kids loved it. Now, I said there were two doubles. Another double is Mazar. Now, if those of you who know where Mazar is, we're in the Big Dipper. Hopefully you can see the Big Dipper there on the screen, okay? Yes?
Yes.
Okay, good. Now, Mazar is right here in the handle, or as we like to say, it's in the next to the last star in the handle. Now, if you look at it the other way, you can say if you start at the end of the handle and work your way in, it's the second star in the group, but right there in the constellation. Now, if you notice in this, I'm going to make this a little bit bigger. Mazar is shown with another one there right next to it, which is Alcor. And that's the beginning of our double structure that's there. An interesting story with Mazar is that it was used in the early years, way back when, a couple hundred years ago, by the Arabs as a vision test observation star to work with their young people. They would stand there and point their kids up to it and say, tell me how many stars you can see. If they could see the double, if they visually, no aid, then they were rated as having excellent eyesight and eligible to do certain other things within the groups. If they couldn't, well, they had a problem with their eyesight. That was an interesting story to me, so I decided to start experimenting with it in the outreach stuff. And I love to get a family, young people, older people, and we would look at Mazar. And the beginnings would go along and tell me how many stars you can see there. Pointing to the second star on the Dipper was relatively easy, and we had laser pointers and we could point them right at it. The young kids could always see too. Some of the adults, not so always, but most of them could. But that's not where the fun starts. Here's another view of what we're looking at. And up here in the upper right-hand corner is the Mazar group. And that's not that far off of what you might see if you looked at Mazar through a finder scope. And what we were doing, every once in a while you'd ask the young kids, can you see anything more than the two stars? And there would be this little squeaky voice that would come up and say, I see three. There might be another one that says, I see four. Well, did they really? Wasn't too sure, but the three is a possibility, especially with young people with good eyesight. And what they were looking at is this combination right here. The two bright stars are the physical pair that most people see when you point to it. Where the 3 and the 4 come from are in these two stars. Those with very, very good vision would be able to see at least 3. I'm talking about in the outreach, working with the young people standing there at the scope, not looking through the scope, but looking with their naked eyes. And then you let them look through the finder scope and they see it and they go, oh, wow, that's interesting. Anyway, those were my two starters and they were always a favorite. Moving right along. So what is a double star? What are we really talking about? Well, there's an example right there, but I'm looking at 4 stars. The simple definition of a double star, and I quote it right out of, where'd I get it? From Wikipedia. In observational astronomy, a double star is a pair of stars which appear to lie close together in the sky. This can happen either because of the pair forms a binary system of stars in mutual orbit, gravitationally bound to each other, or because it is an optical double, a chance alignment of 2 stars in the sky that lie at different distances, but to us they appear very close together. Well, what we have right here is a double star. It happens to be Struve or STF 304. And if you notice in this particular image, how many stars do we see? Well, there's lots of stars in the background, but there are 2 stars within the circle. That is the double star. Well, okay. Some of the things we're concerned with when we look at double stars are the angle that the stars are to each other and the distance that causes the separation. These are the things that we try to resolve. The main objective on a double is to at least be able to split it cleanly. This is a clean split. There's space between the dots. How do you tell the angle? Now, on all the images that I'm going to be showing, you'll usually find out the bottom some information which tells us what it's supposed to be. And the precise PA or alignment degrees is, in this case, 289 degrees at 26 arc seconds of separation. How do we know that's 289? Well, here's our directional reference up here. I've got north up, east to the left. And my alignment to true is pretty darn close in this case. So if north is up here, if we go over to east, that's referred to as 90 degrees, 180 down at the bottom, and 270 over here. Notice that our secondary star is basically over to that left side and up just a little bit, working its way towards the top. So something a little greater in this case, just looking at it visually, something better than 270. Well, the projection is 289. Now, another thing that I'd want to try and do is try and figure out what the distance of separation is. Hard to do with what we got right here, but I'll cover some of that a little bit later. Now, I mentioned this is a Struve object. Oh, my mouse covered something up, which is not good. There we go. Okay. Lots of Struves. Notice a reference in the chart here. Elder Struve, younger Struve appendix. So there's multiple Struves. It's a family. The interesting part of the question comes up is, well, when were they observing and how many did they discover? Well, this is a listing which will show us that here's the Struves, the older and the younger Struve. Look when the observations are. Can you read that okay? If not, I'll read it out.
If you can bring it up a little bit in magnification.
I certainly can. How's that?
Oh, much better.
Okay. The Struves were in the 1830s. They're not current astronomers. That's old, old, old. What I'm trying to say is double stars have been around for a while, a long while. A couple of the familiar names, William Herschel and John Herschel. They were discovering double stars clear back into 1790. A lot of them, as a matter of fact, like 800 stars. The Struves have something approaching 6,000 discoveries that they made during their time frame. Herschel's have over 800. But anyway, doubles have been around for a while. There's some naming conventions, but that's where the STF comes from. It stands for Struve. And that's assigned, by the way, by the U.S. Naval Observatory, which keeps track of double stars officially for us. Okay, typical double star. But the world is not typical. Here's a more complex double star. Now I'm going to open up the magnification on this so we can start to see a trend here. If I make that bigger, notice reference to some letters. I think we see here, we see C, B, F, and E. These are designations for stars within an associated structure for this particular double star, which is the structure is Struve 307. So we keep track of a lot of the different information. Now, the area down here at the bottom I will open this up again. And we actually try to figure out or keep track of the position angle and the separation. The separation is always stated in arc seconds, okay? As well as the magnitude of star 1 and star 2. Of course, you have to always have the coordinates and everything else that goes with it. Sometimes you'll see different designations down the middle under the WDS name, Washington double star name. Struve got involved in doing the original discoveries, and other observers came along and added to the structure some of the definitions which they discovered at a later time. Okay. But anyway, that's a little bit more complex. Well, we might say, is that really a double star? The answer is yes, because everything is linked and measured and locked to the A star. The first measurement and declaration is the AB star, 2 stars. And then we get the other letters. We get the C, for example. Well, we had A to C, and then we have A to D, A to E, A to F, yeah, back and forth. But each declaration is a separate double star, but within the structure, there are many different links.
David, are these actual a star cluster versus optical doubles?
Most double stars are visual doubles.
Okay.
They are. Okay.
So when you're talking here, can you tell us when they're actual binaries or tertiaries, quaternaries versus opticals? And does this nomenclature declare that?
Let me bring up the next slide. I'll back up here. Hold on. The dump. Tight pair complex. All right. And all the information that's available, which is down at the bottom, the answer to your question is no. Now, sometimes there'll be a declaration where there's a physical, they're bound to each other. That's what you're looking for, the binary where they're physically bound. Everything else is an optical. By and large, probably 90%, maybe even a much, much larger percent are not true double stars. They are visuals. But we still keep track of them within the structure of the declaration. This up here, the STF 307 is the physical name for this group and body of stars. It would be the equivalent of saying NGC for a galaxy or NGC for an open cluster or a globular. This is an STF 307, Struve 307. And these are the stars that are measured continually, and it becomes important. And there's history of measurements that go back several hundred years, all within the data that's at the U.S. Naval Observatory, which is openly available to the public. And they keep track with their positions. True scientists, true astronomers who are scientists derive a lot of information from those measurements. Does that help?
Yes, a lot. And another question on that same line is, depending on your magnification, wouldn't you be able to pull in even more stars in this group, or is there a specific magnification that they look at each?
Hold that thought. Hold that thought, and I'll get to that.
Okay, cool.
Okay. Now, I had this one up, and I'm going to bring it again. This is a tight pair. If you look, because you asked about magnification, it gets interesting. This is from the telescope, a picture through the telescope. And the question is, what might you think you are seeing there in the middle, inside the circle? Casually, unless you're really studying for it, you might recognize that it's simply as a single star. In reality, it's a double star. And in looking for the separation, over here, I have an enlargement from the crop of a 1 second exposure. This becomes important. I've lowered my exposure down from 5 seconds down to 1 second, which reduces the light that is being collected on each component of the double. And I'm able to enlarge. Now, enlargement means nothing more than zooming in on the picture. I'm not using a Barlow or something like that. With the high resolution cameras that we have today, we can drill down and really get in and look what's there. And if you notice on the enlargement, you should be able to see the presence of 2 stars. Now, is that our double? I said down at the bottom would be an indication of where things should be. This the position angle on this is supposed to be 146 degrees, 90 to the right, 180 at the bottom. I didn't make it all the way down to the bottom, so I'm less than 180 in this case, just observation, and it's rated at 146. So this is our double star. It's also fairly close in. This is a 7-arc second separation of those stars. I am not fully separated in my view. I'm able to resolve with the equipment I'm using here, basically down, starting at 5 arc seconds or greater, I can usually resolve the double. Less than 5 arc seconds and I start having difficulties with the equipment that I'm using, which I could change, but I'm specifically trying to use the equipment at hand. Okay, so different kinds of double stars. Here's another one. Oh, wait a minute. Now, is that a double star or is that an open cluster? It happens to be both. This is a fully classified double star. That's what you're looking at. All of the objects in there. Now, you asked a moment ago if you could see other stars within your view if you had more information. This will start to address that. In this particular grouping for Struve 484 and 485, there are 21 visible stars in this system that are classified, measured, and we keep track of them, okay? This is the data on those stars. Now, can I see them all in this particular picture? Probably most of them are there. I'm looking at the lower magnitudes. I get down to 15. I can resolve usually mag 14, and I see a 15 in there. And so I'll say those stars are probably all shown in this particular picture. Okay, but anyway, that is literally a double star. It all starts with these 2 here in the middle. Now this is this particular target, and most of the ones you'll be seeing as we go along here are from this book, which we're going to be talking about later by Agnes Clark. And her specified target is those 2 white stars. Look for this double. She and I have had some communication back and forth on when you do that, and I say, you know, Agnes, there's more to it. There's a complete structure there. There's so many more items, but you're only calling out the 2. And it's just a difference of what people are looking for when they're looking at double stars. But here's a case where a double star is actually an open cluster. It happens to be NGC 1502. Now, is that the only one where a double star becomes a cluster? No, there's another very famous one that we have around. Right here, Theta 1 Orionis, otherwise known as the trapezium, the trap. A lot of people know the trap as only being 4 stars. Those 4 right there within the nebulosity of the Orion Nebula. That's the trap. But when you look at what's really there, and this is a good item that comes up in discussion, it's even at star parties, here's the actual commonly used layout of the trapezium. We normally see the A, B, C, D stars, and people have very little difficulty seeing those with a telescope, often with binoculars, okay? But you talk to people that are actually looking at the trapezium with a telescope and you ask them, how many stars can you see in it? Personally, I've seen 6. Okay, let's take a look at the drawing and see what we got. We got A, B, C, D. There's an E, F, G, an H1 and H2, and an I. I've seen through the F star. Now, if you're looking at the stars here, the numbers directly underneath the stars are the magnitude of the stars, the commonly referenced magnitudes. I have never been able to resolve the H's, which are mag 14 and 15, with the telescope. A lot of reasons for that. Some of that is explainable if we get back here. Where is the trapezium? The trapezium is in the Orion Nebula, within the nebulosity. It makes it pulling out very, very faint stars very, very difficult, but it can be done. It can be done. But here's another case where we've got double stars, but it's actually a cluster, a recognized cluster. Now, Tom, to answer your question, do you see more? This is the actual data sheet for looking at Theta 1 Orionis. Look on the bottom left, there's actually 20 visible stars in the system. Where we're looking at what's saying, can we see 6 or 7? There's a few more than that. Looking down the Mag 2 chart, which is the dimmer stars, we get all the way down. Oh, here's one, Mag 17.6. When's the last time, Tom, you saw a Mag 17 star?
I got kicked by a horse once.
Oh, I don't think I can say I've seen one, and I don't think I can say I've photographed one where I was able to record it and identify it. But with the right equipment, you can. The right aperture, the right focal length, good skies. There are 20 visible stars, and the dimmest one on record is 17.6. So yes, I think that answered specifically your question. Okay. Now, there are different types of doubles. I think I may have mentioned this, but I'll mention it again. There are visual binaries, that's probably 90% or more, spectroscopic binaries, eclipsing binaries, and astrometric binaries, as well as exotic types. There are over 100,000 or so known visual double stars. Only a few thousand of those have computed orbits. Orbits, what am I saying? Where one star is revolving around the other. That's the eclipsing binaries. But only a couple thousand there. According to what I've been reading at the U.S. Naval Observatory, there's currently in their records about 180,000 recorded doubles. If you're looking at doubles and want to know how many targets might be available to you, there's a pretty good clue.
Is that just the northern hemisphere, or is that northern and southern?
That's northern and southern.
Oh,
But
okay.
we'll be generous. Let's give it 50% to both, okay? So we're down to maybe 90,000. And if you say, oh, phooey on that, let's cut that in half, and we get down to 50,000. I don't know how long it would take to work through a list of 50,000 objects. I think you could stay busy with doubles for a long time. Okay. I was going to cover something else, but I'm going to skip by that. And I'm going to, in the interest of time, kind of move ahead. When we're looking at double stars, there's some things to think about. Double stars are viewable by most people's existing equipment. Small refractors up and get into even 8-inch SCTs, 10-inch. I've looked at a lot of doubles using a refractor, an 80 millimeter, a 60 millimeter. Heck, you can look through your, through your finder scope and see a lot of them. So it's not as if you have to have special equipment to look at and study double stars. And here, once again, I want to cover the fact that you can, you're not worried about the weather so much. You don't want it raining on you, that's obvious. But you can even work in semi-light clouds by working in pockets. You're not worried about the moon. You can go out and you can just literally all times of the year go out, and as long as you haven't got clouds, and you can do some observing. but things you need to be aware of which make a difference. The larger the aperture, the more light you're going to collect. There's some formulas that work into that. I'm not going to go into some heavy math, but it's available.
Corey?
Rick, you got your mic open? Anyway, the other things are going to be the focal length of your telescope. The longer the focal length, especially, well, not especially, but what it amounts to is the longer the focal length, the higher the magnification that you're going to be working with inherently. So aperture and focal length are big factors in deciding how much you're going to be able to see and how tight you can look at for double stars. I'll go ahead and close that one down. We were looking at measurements, and they were making measurements on these things way back a couple hundred years ago. And they didn't have cameras to take pictures and make precise measurements. They had to do it based on visual. And this is the kind of eyepiece or device that they would use in trying to make those measurements. They would have to know where north was. And if you're doing it visually, you would still have to do it using something like this. And this is within an eyepiece, and you would have your stars in the background where you can actually measure the angle. And then along the scale here in the middle, you'd be able to calculate based on calibration what the distance was between the two objects. This is referred to as a astrometric eyepiece, okay? One of the interesting things to observe from this, if I can find it again, right down here, see where I'm moving my mouse?
Yes.
The product is no longer available for purchase. And this is from Orion. And if Orion's not making them, you're going to have a hard time. They're available used on the market, but they're very, very difficult to try and get these days. But if you're doing visual, this is what you've got to use. What they look like if you actually had the eyepiece, it'd be something like this. It'd be like a standard eyepiece. There would be this part, which it would be lit. So it would light up the radical and you'd be able to see the lines. And then you would see it. And this is showing a star in the center is what it's doing. And that's what where you would actually make the measurement, both of the angle and the separation. That's how they had to do it in the early days. They didn't have an eyepiece this fancy, but they would have an eyepiece that would give them the gradual, and they would then make the measurements. Okay. Moving right along. What can you expect to see? Like I say, I am able to get down with my equipment, and I use, well, today I'm using a C6 for working with my double stars, but I used to use a C8. I still have the C8, but it's in storage. I use a C6, and I can get down and measure down to about 4 arc seconds of separation and see it visually. And I can also do it with the camera that way, and I can capture it. Most lists, when you're looking at double stars, will be more than 4 arc seconds. I can tell you there is a lot of people that take pride in being able to have the equipment to get down and look at all the way down to 1 arc second and sometimes below separation. Very difficult to do. That could require some specialized equipment, like maybe a 10-inch or a 14-inch. You need lots of focal length to get the magnification, and you need some aperture to bring in the light. But if up and down to about 5 arc seconds, you can do it with a C6 or a C8. I do most of my observation today at 77x. That's what the camera is with the C6. When you talk to people who are doing a lot of double star observations, you'll hear them talk about they're operating at 2 or 3 or 400x to be able to see the double. Those are the ones that are chasing the 1 arc second separations. You've got to get the magnification up that high. Little harder to do. Okay. Cover
What's your
show.
camera?
Pardon?
What is your camera?
The camera I use is right here. I've got a couple different cameras for when I use the double star with the C6. What I'm using is a ZAO. It's an ASI 1600 mm, which is a black and white camera. It's a pro, so it's cooled. And that camera with a C6 and my magnification is about 76. And I can do exposures down in like 0.01 seconds if necessary. Why you would try to get your exposures down that kind of low is if you're trying to reduce the amount of light you collect from the brighter stars, you've got to shorten your exposure. If you were to do like 3 and 4 second exposures all the time, you're collecting a lot of light and things start blossoming on you. My standard, which I try to bring the doubles in on, in this particular case, this is 5 seconds. And most of my images are 5 seconds. I can then usually bring in enough background stars to plate solve the images. When you start getting down at in 0.1 seconds, you're not able to gather enough data to do a plate solve normally. However, when I get into a situation like that, I'll do a 5 second of the larger area, and that gives me enough to plate solve where I'm pointing. And then I'll take some exposures down at the lesser values and try to do the splitting. So that is something that happens. Here's the case. This is a 5 second exposure. This one, which I was using to actually do the split, was a 1 second. So that's where I would take different exposures of this of the stars. Okay. A point I'm reading some notes off my other screen here, so excuse me as I got to move that up. The one thing I've stressed this a couple other times, I'll say it again. One thing with double stars, if you're looking at double stars, you'll never run out of targets. There are thousands, hundreds of thousands, really. Well, what did I say it was on the Washington double star catalog? 180,000. There's a few of them out there. I spent a lot of time looking for Struves, STFs. There's about 1,000 of those, and I haven't got them all. So some things that are good there. Okay. I hadn't thought about that being there. That's going to present a problem. Hold on, can I move this? Ah, I can. Okay. Some more images of different types of doubles and things that you might see. What I'm trying to do by presenting these pictures is whet the appetite for some of those you who might be interested in looking at some double stars that you haven't perhaps looked at before. This is a Struve STF 60. It's also a Herschel object. Herschels are something I'm very fond of. But anyway, in this particular view, there are 10 visible stars within the structure. And if you look up here, here's the H star. See how I'm moving the mouse? It shows up here at the top of the picture. The main circle is the close-in area. And I take that and I've expanded it down and enlarged it from a 2 second exposure. And I'm able to see the A, B. Now you can see this is a close-in, very, very close. And if we look up in our list here, the AB has got a separation of 13 arc seconds. And I've also got the I and the E and the H. I don't have all the stars. And there are, of course, other background stars with the image. Some of the images and the overall presentations are, I kind of like them. They're kind of special. Now, one might ask, do I measure all my doubles? The answer is yes. I use software to measure the doubles. And when you measure using the software, there's a couple of things you've got to know. You've got to know the precise, what am I trying to say? Where's north? I've got to know, pardon?
Orientation.
Yes, thank you. You have to know your precise orientation, because I've got to, first of all, I keep north up, but when you do the measurement, you've got to declare what is up. If in the case, and like this one right here, the plate cell tells me that I'm at 357 point something, but I'm basically 3 degrees off from having north true up. So when I put that into the formula for working with the actual measurement, I've got to tell it I'm off by 3 degrees, and which way. That way it'll tell me the precise angle from the primary star to the selected one that I'm looking for. Kind of fun. That H star up there, by the way, get it down here, H. That's an 8.4 magnitude. It's got some brightness to it. We'll see some dimmer ones as we go. But anyway, that was a nice one, I thought.
A question on that: why include something so far away from your central star? What's the protocol for?
Well, when I'm looking for the structure for Struve 60, okay, this is the structure that you're seeing, and the H star was one of the stars. I'm not just looking for the things that are close in. The distance out to H, by the way, it looks like it's a long way out, but 701 arc seconds. Divide that by 60. Let's just call it 600, and that's what, 10 minutes out. So it's not that far out, really. It just is visually a long way out in the picture.
Okay.
Okay. Here's a case where we've got a really small secondary. The main picture, it barely shows up. But an enlargement of the center of that picture is showing where you can see the B star there up at the top. And I will tell you that this is a true double. Only 2 affected stars involved. Everything else that appears in the picture is just there. It's not part of the structure. Big difference between A and B. Now, I want to point out something. When you're looking at double stars, do you have a big one and a little one? Well, in this case, the answer is yes. In other cases, the doubles will be of similar size. So you're just basically looking for the existing structure as it was discovered. And there'll be all kinds. That's the nice thing. No 2 doubles are really the same. Again, most of these images come from Agnes's book. Now, here's a case where we have things that are really tight and dim. Here we have the AB, and I've got an I and an E, but I don't have all the rest of them. Why? Oh, I already showed that one. That was the one with the H up on top. I'm sorry. Grabbed the wrong one. Okay. This is a very complex one. I've got a lot of stuff in a tight area, one outside the circle, but the circle is only of my making, of my choice. And this is the area of concentration. That one's out of the area of my concentration, but I went ahead and marked it as able to identify it. But in all these cases, you'll see where I do a plate solve. I record my information because I need it when I make my measurements, and then I carry the complete structure of the established double star. And you're hoping to resolve all of that. Again, this is at a mag of, basically we'll call it 80. 76 is the number I use, but we'll call it 80. And that's with the camera to the telescope. This would show up very well on most telescopes. Okay, looking for a few more. Here's a case. Oh, yes, this is what I was looking for. Okay, I've got my C out there, but where's the B star? And if you look just off to the left, I'm up here in the upper left-hand corner. If you look off to the left,
Upper right.
you can see B. That took an enlargement. I cropped that area out and I expanded it. Again, this isn't adding a Barlow. This is just working with the image. I need to stress something there. There's two ways to look at double stars, visually and then taking images of it. A lot of people like to do visual imaging only. Did I say visual imaging? That doesn't make sense. Visual observations only. They want to see it and with their eyes and see the split, make any guesses to measurements. There are others who want to take the images. I'm an imager.
Yes, it would be. Just one more thing.
Okay. We were talking about how deep can you go? I'm going to open this up so you can see it a little bit clearer. B is there. I got a larger, smaller star for A and B. But if you look where I have it marked for C, that's a mag 14 star. Now, a lot of people have difficulty even seeing a mag 14 with their telescopes. Mainly, they're dim, but they're also very, very small. With the camera, you can resolve usually down to at least a 14. This is my backyard, by the way. It doesn't, from my observatory in the backyard. I didn't have to go to a dark sky site to bring this in. Now, sometimes it can get a little hairy. Here we have AB in the middle and C off to the bottom. But can you really resolve AB? Not really. If I were to zoom in there, not really. AB looks like one star. That's to the camera, okay? The software I use to actually measure the stars has the ability to really dim and isolate the stars. And I'm able to screen capture the display that it gives me. And the program is called Reduc, from a guy that's over in Europe. Anyway, with Reduc and the tools that are available within that for dimming and isolating, I was able to resolve the AB. So that was kind of rewarding. Okay, one more. Unless that's, no, there's another case where trying to see in the star itself, kind of a little bit difficult, but with the image and using the software, I'm able to resolve it. And the polar law aligned on this is 188.7. So truly the stars are on top of each other back and forth. Okay. So there are a lot of different, I'll move this back out of the way over here now. Targets to be able to look at. Now, one of the things that I really wanted to bring out in this presentation is this. Now, Tom, you have this book, right?
Yes, I have it here. I'll pass it around later on.
All right.
Lights come back on.
The book is Discovering Double Stars by a young lady by the name of Agnes Clark. On cloudy nights in the Double Star Forum, there was a discussion about this book here a couple months back. I want to say close to the first of the year. And it was highly recommended to people take a look at it. This is Agnes. She's a young lady. She says in her book, she wrote the book to help herself find the brighter and better double stars visible from her urban location. She lives in the Netherlands on the southern edge of Amsterdam. Actually, she was born in South Africa. She observes with small telescopes. I want to stress that because it impacts what we're going to try and talk about. She observes with small telescopes, the largest being 150 millimeter Schmidt and the smallest being a 50 millimeter finder scope. Now, since she wrote that, I know that she now has a C6 and is starting to work with a little digital astronomy camera. I believe she's got us out, but I don't know which one. Agnes is a technical writer as her primary occupation, and her writing skills and presentation skills in the book definitely show that skill in her presentation. She's very responsive to customer suggestions for her books and is working on redoing the layouts. Now, the layouts are kind of interesting. The original format is what I have, and Tom, what you have. And with that original layout, I'm going to come up here and I'm going to click this. This is what a page would look like from her book. There would be 2 individual doubles on each page. She provides all the information for them, RA and deck, magnitude, et cetera, and key stars within it, as well as a general description. One of the things that she's been working on is a new layout, and it looks like this. And I'll try and put this here and that over there. Does that work where you can see them both?
Yes.
So you can see the difference. Here we have a layout for each star, whereas on this one, it looks at the general area and shows you everything that might be in that area. This is where the information then would be. So this information over here is replacing it here. Where this new layout, I think, would be advantageous would be for those that might be using a DOB or an Alt-As, where they're with an equatorial, you're usually using a computer driven, and they point differently.
Or like that.
She's going to keep both formats available to the customers. You can make a choice between which one you want to go to.
Yeah, mine has the larger constellation with the double columned one, not the ones that has the red bullet.
Yep.
Descriptions.
Yep. But anyway, there are 2 different layouts. Now, when you consider that, I'm going to try and get to a specific page. Is that it? I don't think so. Nope. I think it's the bottom one. Get out of there. Here we go. Now, do you see that web page?
Yes.
Okay, this is the method by which she distributes the books. In the original release, she had Northern Hemisphere and Southern Hemisphere, and then the all Sky edition. In the new format, if she goes to the newer format, she wants the book to have all of that together. I don't need any information on Southern Hemisphere, so it doesn't really do anything for me. The way they come is in the ring bound field edition. That's this one. And with the ring binder, so that you can open it up, take it with you. It's on a good solid paper. It's good for field use. There is also a paperback edition, a hardback edition, and here's the kicker. If you want to take a look at the book and see if you might be interested, you can download a free copy of the PDF right here from her webpage. Okay. I have the PDF as well as the book, and I use them both. What about the cost? Well, the ring bound edition, I'll click on this so we can bring it up and see it. The ring bound edition sells for about $26. It's not that expensive a book. It is ordered through Lulu. If you don't go for the paperback edition, you order it off of Amazon, but you can't get the ring bound there, only the paperback. And they sell that for paperback at $19.65. You can also get it in hardcover for $48, a little more expensive. As far as I'm concerned, the only one, you know, the one that most of us would probably want or use is what Tom has there and is showing you, which is the ring bound. All right, what have I done? Cancel, thank you. But here on her website, you can find the various and this is where you download the PDF if you're interested. Now, why I'm mentioning all the pictures that you've been seeing as I present are all targets from within her book. There are 300 doubles that are outlined that way. Not all of them will be splittable, visual or by camera, to people with normal equipment. What do I mean by normal? Something less than, to me, a 10-inch is not normal. I know some of you may have a 10-inch. I've got friends that have got 10s and 14s, and I've got one that has a 20-inch CDK. I would love to have a CDK, but not all of us can afford that. Anyway, doubles are a lot of fun to play with. Sometimes people wonder what can I work with? You don't have to go to a dark sky site. You can do observing right in your own backyard. I've mentioned that several times. And it's just it's a biggie where you can start to use your equipment more. Okay, Tom, I've got 8:42. How are we doing time-wise? When are you trying to close by?
I'm not worried about closure.
Pardon?
I'm not worried about any particular time.
Okay, I've got some additional. Save, close, thank you. Go to here. I'm going to make a slight change. I've got another directory I'm bringing up. See, I know you can't see what I'm doing. I have a lot of fun here because I'm actually on a Mac, okay? But I'm running it in a dual mode, or I'm running Windows in a logical system. So I've got two screens. And I will now bring that screen over, and you should be able to see now the Windows display, yes?
Yes.
Okay. I've got some other examples that are good. If we had time, I was going to go ahead and use. Clicking. Oh, where did it open? There we go. Okay. This is a case where we have what appears to be a single star as the AB. I didn't mention that. A is always the primary star of the structure. And the first second component that goes along with it is the B star. And then if there's other components, they'll go up from there. But A is always the primary star within the structure. But here, once again, I used Reduct. That's the software that I use to try and measure. And I'm able to resolve and split that. And that is the proper angle and separation for the AB pair. It gets really, really tight. That, by the way, the AB pair in all series is 3.2 arc seconds. So there's a case where I'm capturing one down to 3.2. I like to say I can normally do 5, but here's a case where I got 3.2. I have not ever been able to get down below 1 arc second, even with the C8. Oh, mercy. Okay, close that. No. Okay. You go over here. This is Windows, dummy. It's in the upper right-hand corner. Okay. Is this one going to open? Yep, there we go. Here's another. My main exposure is 5 seconds for this picture. And I can't see the separation. But when I got down to, remember I said I get down to some real tight exposures? This exposure is a 0.1 second exposure. And I can crop and enlarge that, and I can cleanly see the AB for the split. So doing that visually is going to be kind of tough, but using the camera and trying to capture, it's doable and it does work. Okay, I'm just, like I said, I'm just looking for some different examples, and these all come. This kind of heading down here at the bottom is where I'm keeping track of the information from Agnes's book. And my plate solve is there and the information on the picture.
David, go down to the question and answer and ask and see what the question is that's popped up there.
Go down to questions.
Yeah, the Q&A at the bottom.
Well, hold on a second. I can get there. I've got that minimized for right now, but I can open it up. Here we go. Maybe. What's the question?
Hang on, let me open it up. Let's see. Yeah, I can't read it.
I'm for some reason, I'm not opening it where I can see it. I'm screen sharing, I know. Oh. Where did it go? Where did it go?
The question is, have you been able to see Sirius B
Yes.
easily?
No.
Okay.
The pup. You want to know if I can see the pup? And I have been able to see it, yes. Visually. I have not been able to image it.
Really, you've visually seen it and haven't been able to image it.
People that see it visually are usually normally using averted vision.
Ah, okay.
And when you're looking on it with a camera, the camera is that much light coming, it just saturates the sensor.
So with a bright star like Sirius or any of the brighter stars, any particular filter might help?
Well, yes. For example, when they make a moon filter, most people are familiar with the moon filter.
Yeah, neutral density.
The moon filter, it would be one to possibly even use, but you're trying to turn down the brightness of the moon. The problem when you go to a bright star is if you turn down the light, what is it you're really looking for? The bright star, or are you looking for a dim double? And if you, something like Sirius, if you put a filter on and you try to turn down the light, it doesn't just turn down Sirius, it turns down the whole thing. And your dim double goes away. So that doesn't work. So there's no filter I know of. There's a fellow that lives up in Colorado that does imaging of doubles, and he has been talking about on the forums a technique he's been playing with, working to see some of the dimmer ones and the smaller ones. I think people should know what a Batinoff filter is.
Oh, yeah.
Okay, a lot of us use Batinoff filters for focusing. They produce the spikes. And he actually uses a Batinoff filter when he photographs the double. And what happens is, although the secondary is usually kind of small and dim, it produces the bright spikes. So it will show up where he can see it. He doesn't see it cleanly. I'll call this clean, the one I have in here. He would see the spikes, the diffraction spikes. And he would credit that with being able to find some of his targets.
I was wondering, I've shot a number of tight stars trying to get their spectrum using a diffraction grating. And I know that if I get too close, it's hard for me to split them for the program. So I was wondering if that would, yeah, I'll have to try that on a double star, see what that looks like. Yeah, interesting. Interesting.
Okay, here's a case of, again, a more complex. This is actually where we get two different targets in one field of view. It's not a double-double, but it's in the view, I have two separate double stars. And then one's kind of more complex. This one's kind of simple. I'm sorry, I misquoted that there. This is the F star. So this is actually tied to that system. So withdraw that. But again, it's just an interesting view of a structure of stars. Okay. What I'm hoping to do with this is possibly interest some other people into getting into observing of double stars, where they may not have been doing it up until now. Am I looking for anything special? Yes. Here's a case where I had what I'm looking for in the main picture here. I'll enlarge it. We're looking for A, B, and C. And if I enlarge that, the ABC is the central star. So AB is one, and then from AB to C is a secondary one. D outside further in the ring, but you don't see any real split there. But in this particular case, all right, you got to reduce there, up here in the corner. I don't have a split for AB, but I can cleanly visualize C. It's a fun, you know, it's a hobby for us. Astronomy is a hobby as well as a science. And we enjoy what we do, and it's fun seeing things and identifying things. And I get a lot of enjoyment out of working with double stars, and hopefully maybe some other people will consider doing it. And if you're new into it, I'll move this out of the way. If you're new into it and are wondering what to look for and how to find things, Agnes's book can help you out. 300 doubles with that. That'll keep you busy for a long time. Oh, I know we didn't mention about the book. The book is actually broken up into seasons. You got the 4 main seasons, and then she breaks each season up into early and late. So you don't have to worry about trying to find something within the book of what to look for. You just go to the time of year that we're in, and the objects will be there. For example, I'm working right now on the last 30. I've got everything imaged out of our book except for the, I've got 30 more stars to go, and I'm into the late autumn portion of the book. And that's where I'm getting my targets from. Anyway, okay. Now, where's my funny little thing? That's all the ones I had. It was supposed to be clear tonight, and I was going to put this up here and says, well, I've gone about as far as I can go, and I'm getting this message from my telescope. But obviously it's not clear outside, but this is a new key ring that's out and about. I thought it was kind of cute, so I picked one up. I'll hang it on the wall. My telescope is calling. I must go. Tom?
Yes, sir.
Any questions?
Yeah, we had, I don't know, can you pull up the Q&A? Because hang on a second.
For some reason, I have lost. I got Zoom.
Want to try to stop sharing? If you stop sharing, that might pop it up.
Okay. Stop sharing. Ta-da. Yes, I have it now. Okay, are we in the chat area or the question, or Q&A?
Q&A, please.
Okay. Have I been able to see Sirius B? I answered that one, yes. Bob Mike, hello, Bob. Bob Buckheim. Hi, David, on HJ 15, since you're using a very short, you might want to try this. Oh, okay. Try speckle I can't even say it. Interferometry routine in Reduc. It can tease out and measure very close pairs. I've got some experience working with a group of guys. Bob's one of them. And I got to play with speckle some time back. Speckle is the use of a special camera and working with very tight doubles. And it's a whole different science. And I have not elected to pursue that any further. Now, I don't know if I can use that as a tool in Reduc, Bob. I'll look that up and see what's there. And Bob has another one. If you're using an SA 100 grading or equivalent, take a look at Alberio. There is a surprise in the blue component.
I'll have to do that. Yeah, that's one I'm not sure. I know I have it.
Okay.
I'll have to do that. Yes.
Have I observed any eclipsing binary stars over time? The answer again is yes. Okay, I know what I can do and what I need to do. I've got some time, so I can hit that real quick. One of the places I got to get back into screen sharing. Da-dump, screen share. Main screen share. Okay. From the web, I'm going to go to where all those facts and figures come from that I use, which would be handy if people want to get into it. And that's a place known as Stella Dopal. Okay. And he picked one, which what he said, HJ 1537. So I'll just pull it up. HJ 15. I don't know if that's going to pull. Yes, here we go. Okay, Stella Dopal produces information for each one of the named stars. And it also gives the Washington double star identifier, which is, quite frankly, it's the RA and DEC in their coding. And that's what they use if you ever try to get information from them, which I've done a lot of. This is all the last information that's on it, but right here, that question, Terry Shea wrote in on it and it says, have I seen any of those? And right here is where you pick up some information on this. And it's what it's saying is this double is physical. Ta-da. Okay. And what that means quite literally is that's a true in all respects double star. It's a physical one. It's a true binary. Not all of them are, most of them are not. And sometimes within the classes, I'll see if I can find one here. What? STF, here we go. STF. Lost it, where'd it go? 748. Okay, and I'm going to say, show me this. Okay. Now, here's an example of how you can tell. This is Theta 1 Orionis again, the trap, okay? And when you're looking at the full screen information that's here, you see in this particular column, there's only 2 of them that have a yes in it. And what it's saying is, are there orbit calculations for this combination? And the answer is yes. If you have an orbit, you have a pair of stars that are tightly bound to each other. Now, the nature of this double is uncertain, but what that's addressing is what this line is. And that's just that one pair, which is the AB star. But this one and this one have calculated orbits, and that information usually, oh, I've got to select it is what it amounts to. Let's see if I can show you what one looks like. Yeah, I'm not gonna mess with that right now. But anyway, the actual calculated orbits would be displayed here if I put the right information in. So there are some, yes, there are a few. Here's a case where there are 20 stars and 42 systems within the trap, and we have 2 that are orbiting, all the rest of them are not. So that kind of gives you an idea of what's out there. Most of them are just visual. Okay, I don't see any other questions.
Any questions from the
Yeah,
room?
I've got a question.
Paul has a question. Stand by, come on over here.
Some time ago, I was talking to a kind of a serious double star observer, and I think it was just visual. He said that he locked down the focus on his C8 because changing the focus in that way changes the focal length of the system, and he wanted it to be accurate all the time. And so he put a separate focuser at the back focus. Do you know anybody that does this?
What you're saying is correct, and I understand it. What am I trying to get to here? There's a couple things that can come into play when you're working with double stars and you're trying to get serious about it. One is changing the focus. That's true. But quite often people will change the eyepieces, trying to see it tighter or looser, as the case may be, increase in magnification or lower it for whatever particular reason. Most eyepieces are not what they call it parafocal. They are not precise to each other. You have that little bit of play when you put the tightening screws into the eyepiece. So just in changing an eyepiece, for example, you can move the orientation of the telescope and it'll be different. Then you got to jog it a little here, a little there to get your target back into the center. And that too, every time you change an eyepiece is when you need to be definitely able to change the focus. That can be quite perplexing. I've lived through some of that. And I finally said, you know, I like imaging and I can keep that a constant. If I need to use a Barlow, I'll set up for the evening using a Barlow, but I'll set my focus early on in the evening and then only have to make casual minor adjustments through the course of the evening. A lot of people aren't aware of it, but an SCT, even an 8-inch, even a 6-inch, the focus is going to change during the course of the evening with the change in temperature. So you've got to be keenly aware of that. And if you're trying to keep a sharp image, especially when working with doubles, you've got to make sure that you keep your focus, the ability to change the focus. Now, when I use an SCT in the observatory, I have an electronic motor to change the focus. I don't have to use my fingers on my, and that's why, because that becomes very, there's no movement when you're touching the scope. You just use the motor and let the motor make the change.
Yeah, this guy apparently is claiming that, you know, if you wanted to really make an accurate separation measurement, you had to know the exact focal length of the instrument in, you know, millimeters or what?
Not correct. What you do need to do is be able to do a plate solve and know what your scale is.
Well, that.
Oh, okay, wait a minute, you're saying visual.
Yeah.
Yes, that's correct. That's correct. So he's being, and you have to know what the scale is that you're working with. In other words, you have to, when you're doing visual, before your measurement is made, you have to do a calibration. And the calibration, you have to go to a known pair and set your scale for the calibration. Then you go to the pair you're measuring, and you don't want that focus to change. It has to be precisely where it was when you did the calibration. That is correct.
But the reference pair that you use to set your calibration, what came before that? Somebody had to be the first to determine what exact number of arc seconds they were dealing with.
I have no idea. Best answer I can give you.
I think if you know the focal length exactly, then you can determine that by focal length and eyepiece and so forth.
It's a math model. One could probably find the formula for it. But you say, what did they use originally? I'll send John Herschel. I'll send Herschel's an email and see what he says. I'm joking. I don't think he would ever respond to an email. He's been dead a long time.
Hey, thanks.
Okay, you bet him.
Any more questions? All the Q&A questions?
All done.
Okay.
I thank you, everybody.
Well, David, I really enjoy that. I really especially enjoy being a pseudo novice talks about actual observing, visual observing. It's nice to hear about Artemis and some of these other things, but I like to know about how to do more visual stuff. And by the end of the year, I hope to have my cataracts removed and I'll be back to actually being able to see crap in the eyepiece, which has just really gotten terrible. That's why I've gone strictly DSLR when I'm out, because I just can't see squat anymore. So anyway, so I'm going to pass the, oh, you've got the full screen up. So anybody want to see the book? Yeah, pass it around here. It's really interesting. It's real easy, I think, to use. Even a guy like me can use it because it's not involving Zoom. I mean,
you are going to celebrate so much when you step away from Zoom.
Tell me about it. But I think Zoom's here to stay, because I think most of our presenters from now on will want to be Zoomed in. And, you know, I don't blame them, but geez, Pete, I need some young guy. Let's see if I can get my grandson in to run the meetings. Of course, he doesn't.
I think EVAC right now, Claude's having similar issues to what you're describing, okay? And
Well,
I believe
about it, but yes, I've watched some of their meetings and it's like, woohoo, it's not just me.
they've got actually a technical person there running the Zoom part of it.
Yeah, well,
He's off to the side.
it's me and Jack and every volunteer here that wants to give me advice about how to fix this thing. And thankfully, we had somebody that Mike Poppery showed me. He said, no, go over on the side here and you need to look at this particular thing. It's like, I'd never seen that before. And yeah, so wow. Yeah, exactly. Jack Jones says for what we're paying them, they should send us a rep. Of course, it's all for all things are now online. So anyway,
they'll be glad to give you technical information on Zoom.
yes. Well, Rick Rotrammel, anything you want to say? You want to pop your mic back on and anything about the newsletter?
Well, I hope everybody reads it.
One more time,
Enjoys
can
it.
we read it? Yeah.
Give him some feedback.
Okay, you've all heard it. Let us know. And if you know of anybody who might want to be our guest presenter on whatever topic out there, please let us know. I'm still struggling to find people. I was trying to get the people from Mount Lemon to be Octobers, but they've kind of palmed me off. And then Dr. Windhorst from ASU hopefully will be our November speaker, talking about the James Webb and the stuff that he's been doing on it. He put us off till November because he wanted to have some data to show us, but he has not responded with a positive that yes, he will do November for us. So it's all kind of on hold. So we're still looking for October. And if he blows us off, then maybe we'll get the Mount Lemon people for November, and we'll struggle and find somebody for October. Remember, all of you who are doing things, who would like to present your little niche activity, by all means, we'd like to see it. And if you want to write a short article for the newsletter, I'm sure Rick would like to print it. So if that is it, let's see, did we have any questions in there? The way I have my screen set up here, stand by. Since we finally figured out how to make the screen on our projector work, I can't now see my laptop, so I can't see the questions on the Q&A until I go up to see the main screen. So anyway, if that is it, then what we're going to do is end the meeting. Remember, if you want to pay your dues for next year early, by all means, please do. And give us your comments about activities you want to be involved in. Remember, if we want to do an October or November star party at T-Bird Park, we need to get some help in organizing it. Jack's out of pocket for that. So until then.
Before you hit it, Bob Buckheim put something in the Q&A, which I'll read to you. He says, one of the old time tricks for determining focal length was to rely on the drift of the star when you turn the drive off. So that would go to answering
Paul's question. Yes.
Yes. So that gets that information to him. And then that's it.
Yeah. Paul says do that at the equator. Okay. Okie dokie. Well, then this is it. That was that. 1, 2, 3. Meeting's adjourned. Thank you all for attending, especially all the numerous participants. I think we're up to 22. Thank our guest speaker tonight, David Douglas, and hope to see you out in the desert soon. Talk to you all. Be seeing you.